Okay, so here we are with question 2 of the 2017 paper 1. Okay, and this is a complex numbers question. Love these. Okay, very standard, bog standard question. So let's get stuck in now. This is a 5 marker or 5B scale, so there's only mid partial, so low, 0, mid partial, high partial, full marks. Okay. Now part A here, the complex number Z1 equals A plus BI. That's just telling you that'll be in that form. Okay, so don't worry too much about that. Where I squared is equal to minus 1, now you may or may not need it in a different question. Okay, but this will help you get out of a situation. If you see I squared appear, you can swap them. And you're shown a blank Argand diagram here. Okay, now you're actually, sorry, it's not blank, there's a complex number Z1 is marked on it. You have to read off the real part and the imaginary part. Okay, so the real axis is the equivalent of the x-axis, so it's at 3. So that's the A here in the complex number, A plus BI. The complex number you have is 3, okay, and then the BI, so where is it on the imaginary axis? The B value there is -1, so that's -1, okay. And technically the complex number is 3 minus 1i, but that corresponds to the question there, A plus BI. So A is the 3, B is the number in front of the I, so it's the -1. Now the answer just given there. Okay, so that's A part 1. Now A part 2 here, we're asked to plot -1 plus 2i on the Argand diagram. Now the hit or miss is either right or wrong. Okay, it's very unforgiving in a sense. So very careful. The -1 there, so it's -1 on the real axis, so it's somewhere along this line that I'm marking here. Where does that cross with the imaginary axis and the 2i on it? So where these dotted lines meet, okay, if that's the intersection, okay, that's your point. Okay, so make sure to clearly label it, okay, a big mark, whatever, and Z2. Okay, now in the answer here, I was doing wrong. No marks for me. Okay, so apologies. Okay, of course that was meant in order to point out the fact that it's so easy to make a mistake, especially on a hit or miss question. But it's -1 on the real axis and 2i on the imaginary axis. Okay, so it's actually -1 plus 2i is up here. Okay, now if you do make a mistake, just cross it out. Okay, and remark it. This is, I suppose, an example. You're kind of pushing it, but if the answer I've just written and declared was wrong, the person can see, the grader can see the marking here. It's still visible. So if that actually had been the correct answer, I still should get full marks. Okay, and there we are, -1 plus 2i, which I've just realized is actually wrong in the notes. Okay, that line should be up there. So I'm going to stop this and okay, so now that's fixed, and I apologize for that complete and utter disaster. At least I suppose I caught the mistake. And that's, so again, that's -1 on the real axis and 2i on the imaginary axis. Okay, so part 3 here now, it's again, as I said, the complex number question to me is basically bog standard. Here's division, complex numbers, and they're asking me to prove that, or find, a complex number Z3, and that's found by dividing complex number Z1 by complex number Z2. Okay, and you write that in the form of x plus yi, which is the equivalent of A plus bi. Okay, it's just a different way of saying it. And it's saying here where x and y are real numbers, basically any number. Okay. Now the hint here in the bottom, okay, if you want to divide a complex number, you need to multiply top and bottom by the conjugate of the bottom. So you need to know what the conjugate of a complex number is. Okay. If I go to my answer here, the conjugate of -1 plus 2i will be -1 minus 2i. Okay, so at least write that down, and you got marks for writing down the conjugate. So I've written the question out again. So Z3 is found by dividing Z1, which is 3 minus i from part A, divided by -1 plus 2i from part 2. Okay, and then you remember the rule: you multiply top and bottom by the conjugate of the bottom. So again, the conjugate of the bottom is -1 minus 2i. So multiply top by it and bottom by it. So as long as you're careful now, okay, you can use a rougher column. You don't have all that much space in the exam paper. I'm expanding it here, top and bottom of the fraction there, okay, and then dealing with it and simplifying it down. There's no right or wrong with that, okay. So I'm following the classic method of writing the second bracket out twice, multiplying the first term into the first bracket and the second term into the second bracket. Again, you don't necessarily need to do it that way, okay, but you're less likely to make mistakes if you're following a method. As I often say with maths, you're building up a bank of skills in class and which you study and practice, and then you apply those skills in the game, in the exam, or in essence, sometimes you're just being asked to prove you know the skill in a very formulaic way. In this way, you're being tested. Can you multiply two complex numbers? Okay. And then, whatever way you do that, as long as it's correct, you're fine, okay? But if you do it in a methodological way, that's the word, then you will be less likely to make errors, and therefore pick up more marks. But also, the marker finds it easier to follow, and to judge where on the scale. Now, this is a 10D scale, so low partial 4, mid partial 6, high partial 8. So you're looking to get as far along that chain, and ideally, if you can, the full 10 marks. So if I go on, okay, I'm doing the same thing on the bottom part here. Okay, I'm writing the second bracket out twice, multiplying the first term into the first bracket and the second term into the second bracket. I now go top to bottom, left to right. 3 minus 1 is minus 3. 3 by minus 2i, plus by minus is a minus. 3 by 2i is 6i. Minus I by minus 1, minus by minus is a plus. 1 by I is 1i. Minus by minus is a plus. I by 2i is the same thing as 2i squared. Now I go onto the bottom. I've done all the work I can on the top line. Okay. I'm multiplying the minus 1 by minus 1 gives you the plus 1. Minus 1 by minus 2i gives you minus by minus is a plus. Anything by 1 is itself, so 1 by 2i is 2i. Move on. Plus by minus is minus. 2i by 1, so anything by 1 is itself. 2i by 1 is 2i. Lastly, 2i by minus 2i plus by minus is minus. 2i by 2i is the same thing as 4i squared. So now we come along and I can do two things here. Okay, I can add like terms. Okay, so the 6i, so the minus 6i plus I be minus 5i, and then the 2i minus 2i will cancel and give you 0. You'll always find in division of complex numbers that on the bottom part, the denominator, the i's cancel. Okay. At the same time up here, I'm writing down the grouped terms as such, and the answers to them, but I'm also inserting minus 1 for I squared. And I'm giving a reminder here of that fact. Okay, and you were given a reminder of that in part 1. That's going to change the sign of both those I squareds. That's the ultimate effect of it. And I end up here with minus 3 minus 2. So minus 3 minus 2 is minus 5. And the minus 5i has not been changed. And the bottom line, you're going to end up with a number. All the i's have gone. So I minus 4 times minus 1 is the same thing as 1 plus 4. 1 plus 4 is 5. Okay, now I could leave my answer like that, but that's not in the form they asked me. Okay, they want in the form of a number plus a number times I. Okay, not a number plus minus a number times I all divided by a number. Okay, so one of the rules of fractions is I can split this into two separate fractions and divide the 5 into the minus 5 and the 5 also into the minus 5i. So you end up with that here. If you actually do the division, 5 into 5 goes once, and 5 into 5 goes once. So you're left with minus 1 minus I. Job done. Okay, so last point on this is very simple. You should know how to do the operations in complex numbers because it comes up very often. And if you do know how to do them, the questions can be very formulaic. Okay. Now I think here we're almost finished. Okay, this question is dragging on. We're on part B here, solve for Z, okay, or Z, whatever. Now, if you see here, you move along, okay, you have Z, you have an I. So, really the unknown is Z. So, like any algebra, you want your unknown on one side, and you want everything else the far side. Okay? So I'm doing here, I'm going to go left to right first and see can I simplify it. And I'm going to go to the answer here. So I'm multiplying the minus 6 into the brackets. So minus 6 by plus 4 is minus 24. Minus 6 by minus 6i is plus 26i. Okay. You move on then. That's again, we're practicing here multiplication of complex numbers. So you write one bracket out twice. Okay, first term in the first bracket, second term into the second bracket. Now, the next line, I'm going to simplify that. Okay, I should just remove brackets as such. So my left-hand side here stayed the same, and I'm multiplying out the brackets. So minus 1 by 4 is minus 4. Minus 1 by minus 2i is the same thing as plus 2i. I by 4 is the same thing as 4i. I by minus 2i is the same thing as minus 2i squared. So this I squared is going to need to be dealt with. Okay, and we've seen what we did the last time in part 3 of part A. I'm going to swap that with minus 1. And the ultimate effect will be that this term is going to change sign. And by 1 is itself, it's the minus is going to affect the sign. I then end up here, if I jump down this far, okay, and in that intermediate step I've joined the 2i and the 4i to give 6i. And then in this step here, I'm moving on. The left hand side is still the same. Minus 4 plus 2i is the same thing as minus 2. And the 6i just carries over. So I'm getting there, okay? I've taken away all the brackets. Now I'm going to move everything to one side, okay? So I'm bringing the minus 24 across the equal. Now what's subtracting on the left becomes added on the right. That's it there. The plus 26i was added on the left, becomes subtracted on the right. That's it there. Okay. Then join like terms. So 2 and minus 2 plus 24 is the same thing as plus 22. 6i, take away 36i is the same thing as minus 30i. Then divide across by the 2. Now I haven't done that here. Okay, but basically you're moving this 2, it's being multiplied on the left, comes across the opposite side, becomes divided. So you end up with 2 into 22 goes 11 times, 2 into minus 30i goes minus 15i times. And that's your answer. Okay, now that should be the end of the question. Okay, so that's the end of question B. I'll leave it at that because we're running up to 12 minutes. And thanks you, and see you on question 3.